So last class we had covered abstract classes and interface. Today we'll take another topic that is like nested classes. So nested classes are like classes within classes, and this is a bit advanced topic, and you may not always use this very often, but there are some times that you might want to use this. You can also do without using nested classes, but there are certain advantages that you can get while you use these nested classes. It won't be like applicable at every place that you can use these nested classes, but there are some places where you might feel that there's a need for nested classes. So I'll explain that to you. So what basically like these nested classes or inner classes are. So suppose you have an outer class, something like class outer, and then you create another class within that class. So this is kind of like nesting. So you have already seen those if else blocks, right? Where we were able to like write nested if else conditions. So this is kind of like the this is kind of similar nesting. So by nested classes we mean that there's an outer class and there's an inner class created within the outer class. So what is the practical application and why this was like introduced in Java? So one thing is like when we want to logically relate the classes, so if those classes are very much related to each other, and what happens that that particular inner class that we have created is not widely used to the other parts of the project. So in that case you might choose to have a nested class approach to develop your program. So see, suppose the inner class that we create is not very widely used and it's not applicable to other parts of the project, and you want to use this only in the class that you are creating in the class that you are creating. Suppose you want to access these things only in the outer class, and you want to like restrict the usage of the inner class somewhere outside. So in that case you might choose to create a nested class or an inner class, and what that does is it basically logically relates your two classes, and also it does is it makes the code clean and readable. So that is also one thing, and it helps you to basically there are certain things that are like accessible as well. See, we had studied that the private methods or the private variables, this cannot be
Oh,
accessed.
did you show? Or
Hello, yes.
can you show? It didn't show.
Are you not able to say uh,
No.
okay? Oh, am I not sharing my screen? Okay, wait a second. Okay, I'll have to like uh, one second. Are you able to see my screen now?
Now is there. Now you share it.
Okay, 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 one second. You're able to see the slides, right?
Yes, now it's good. Yeah, now I know.
Okay, yeah. So I was talking about like nested classes. So in Java, basically, there are some use cases of nested classes. Like when you want your inner class not to be accessible to most of the other classes, and you want to use it only for a limited class. So in that case, you may choose to create the nested classes. And what it does is it also makes the code clean and readable, and it also helps you like to optimize the code. And Also, what happens is like when your inner class is not very much used outside that class, you do not want to create it and like simply import it in some other parts of the workspace, right? So that is one thing. And other is like the private methods of the outer class and the private variables of the outer class, right? That can also be accessed when you are basically using this inner class. So there might be some design where you want to sometimes use your private methods as well. As of now, we have studied one thing, right? That these private methods cannot be like inherited by any of the other classes while we were covering that access modifiers. But this is like getting to use those private methods within the inner class. So these are some of the benefits that inner classes basically offer you. So once again, like this is not a very popular topic that I'm covering today, but sometimes this is one of the advanced topics. So once you like get to create your project and start using, so on an advanced level, some use cases will be there when you want to like use these nested classes. You can also do away with this and create separate classes and try to use them, but this is like one of the features that Java has provided. Sometimes you might uh, want to like optimize or make your code more clean and readable, so sometimes you can choose to use inner classes or nested classes. So we'll see. So basically there are like four types of nested classes. I have not included one here, so because that is not very widely used, but I will write it down over here. One is like method local inner class. So these are the four types of nested classes that Java has, like static nested classes, inner classes, anonymous inner classes, method local inner class. We'll go over each one by one. So let's go with static nested classes first. See, static nested class is associated with the outer class and not with an object of the outer class. So when we say something like static, we already know that that is at the class level. So anything when I speak of a static, that is related to the class. This we had already studied, right? When we were seeing the static methods and static variables. So this is similar to that. A static class is basically associated with the outer class. So consider this as one of the, say something like static class is like another method only. So this is like associated with the another, this is associated with the class name itself. So this static class or the inner class is associated with the outer class and not with the object of the outer class. So basically to access any static methods or static class, you can choose to use the class name dot method name, right? Or if you want to like access your static variables, you can choose to use your class name dot variable name. So that is how you can basically access. See, the static nested class acts just like any top level class, except that its name and accessibility are defined by enclosing class. So this is also a kind of uh, you can say a data member or a top level class itself, but it's like we are enclosing some piece of code in that inner class only. So to make some code concise and brief, we are creating an inner class and we want to like write down some functionality in the inner class. That is why we basically choose to create an inner class. So a static class cannot access any outer class, instance, field or method. So this we already know, right? In a static method, we cannot access the non-static methods or the non-static variables. So non-static variables are also called instance field or methods, right? So similarly, in a static class, we cannot access the instance field or methods of the outer class. Suppose our outer class has some data members or variables, and those are like instance field or methods. So we cannot access those in that static class because this is static. Static can always access static methods and static variables itself. So that restriction is on static methods here as well. So we'll see the demo of this static methods, static class. So this is kind of like a static member of the outer class itself. So we'll see that in the demo. Let me try to go ahead and create a demo such that this is like more clear. I'll create a new package. I'll create a new package like inner class. Okay, one second. Inner. And then I'll create another package, static. Okay, that's giving me an error. Why? Because static is a keyword. So let me try to static dot. Okay. Okay, let it be. We already have a package like this. So let me try to go ahead and create. Or let me just create an outer class. So we have something like this, public class outer, and what I will basically do, I'll create some static methods. Let me create one static method, private static. I'll print down something here. Okay, so this is one of the static methods that I created in the class. These things we have already seen, right? How we can basically create a method, static method, non-static method in a class. Now let's go ahead and see the example of the static class. So let's say we create something like class inner, and what we basically do, we basically associate associate the keyword static before this class name. So now this class is static. This is like associated, this static class is basically associated with the outer class. So anything that we create a static, right? Even if we like create this method a static, so this is associated with this outer class. And similarly, this is like another class, and this class is static class. So this is also associated with this outer class. So That is the thing. Now let me go ahead and try to create one method, one static method inside this static class. See, a static class will basically have static methods only. So I'll create one static method. Let me create something like this. Let me print out inside inner class static method. So this is the only piece of code which you had not seen until now. What I basically did, within the outer class I created one method, and this is static inner class. This is static inner class, and within that inner class I have like another method. So this can have another static method. So I created that, and now what I will basically do, I'll go ahead and outside of this static class, means inside the outer class, what I'm doing, I'm going ahead and creating a main method. Here we'll basically see how we can access the outer class methods or inner class methods. So let's see how this class is associated with the outer class, how the static class is associated with the outer class. So we know that we can access this with the class name of the outer class, right? So what you will do, we'll try to use outer, then we'll try to use inner, and then we'll try to use print. See, if there is anything, why we first use this outer? When we use this outer dot, we know that we are using the outer class name, and anything associated with this will be accessible, right? Outer dot outer method is also accessible, outer dot inner. So this inner is a static class, so this is also accessible. So let me write down inner, and when I do this dot, so what are the things now available in this inner static class? So in this inner static class, there's another static method that is available. So what I'll do, I'll call this print. Let me try to run this. See, we were able to call this, right? We are able to call this method from the outer class. So see, the basic application is that you are creating some application already, and all of a sudden you feel that there's a need to create a class where I will have some functionalities which will be like limited to this class itself. So in that case, what you can do, you can go ahead and create something like static class, provide some functionality in that method, and then you can like access this. So for accessing the inner class methods, what you will basically do, you will create this outer. When you do this outer dot, then all these things are like accessible. This method is accessible to you, this method is also accessible to you. So sorry, this class is also accessible to you. So once this class is accessible, you know that this class is also a static class, this class is also a static class. And then what you can do, this is a static method, so this can be called using a class name. So inner dot print, so you can call the static method of the static inner class. And how do you call the outer class method? What you can do, outer dot outer method. If you do this, let's try to run this program. See, inside the outer method. You can basically access it using this. So this is one of the examples of static nested classes. We'll keep the example simple only such that it is like very clear to you. So we did not do anything special over here. We just created a static inner class. We created a static method within this, and in this main method, basically we are trying to access the inner class methods. So how basically this method can be extracted out of the inner class, how this can be invoked. So to invoke this inner class method, we can use this outer dot inner dot static method. So this will basically call the inner class static method. Is it clear? Okay, I'll just write down static nested classes. So next is there are like another classes like inner classes as well. We'll see how we basically create the inner classes. So inner class is like that internal class that we create is not static. Means now we saw that this was static nested class. So the inner class that we are basically creating, that is termed as static. So what difference an inner class will have is basically we won't have this static. So that's not a static inner class. That's simply a inner class. We'll see this demo. Okay, let's say we have something like uh, let me try to like create a different package such that these things are in a different inner class. Okay, so inner class is inner. So we'll create something like outer class here. I'm closing this. So now we'll see how we can basically use inner classes. So this is like you can also say this is nested inner class. So earlier we had seen this example where this example was about static nested classes. So the inner class that we created was basically a static class. Here we'll create an inner class that will not be static. So what we can basically do, we already have this outer class. So in this outer class, we'll create a inner class. Let's say we created something like this class inner. See, We had done the same thing in the previous example as well. So what was difference? We had this class as static in the previous example. Now this class is not static, and I'll do something. I'll go ahead and create some method, public void uh, print, let's say welcome to Java training. So we are printing something like this. So this is where our class ends, inner class ends. So outside this, what we would do, we will go ahead and try to create a main method which will help us in calling the methods. So see, this is our inner class, and this is the method of the inner class. So how we can basically access this? How we can basically access this? So in the previous example that we saw, we had a static inner class and a static method in that inner class. So anything static would be basically called using a class name. But here this is not static class, right? And this is also not static method. So what we'll basically do, we'll call these things using the object. So anything which is like non-static or instance, right? So this is like a non-static class, and this is like a non-static methods. So any such thing in Java will be basically called using a object. So let's try to go ahead and try to call this. So for creating an object of the inner class, what we'll basically do, we'll basically do something like, so see, this inner class will not be directly accessible here, right? So first, to access this inner class, in the previous example what we saw, to access the inner class, we had to first use like outer. So when we did this outer dot, so all the static things, all the static methods, all the static methods or the static classes were accessible, right? So similarly here, here what we'll basically need to do, we'll need to create an object of the outer class, something like this. And when we do this new outer dot, so now we can basically create object of the inner class, something like this. And now what we can do, we can basically call this print. So this is one way you can do. So another way is like you create the objects and then you assign it to a reference. So what you can basically do, outer dot inner object, something like this. You can assign this. So you already know how to create an object, right? Class name, a reference variable is equal to new class name parenthesis closed. So to create the inner object, will basically do something like this, outer dot inner. So this gives me a reference to this inner class, and then what you will basically do, you will create an object of the outer class, and then from that object you create the object of the inner class. See, this syntaxes we have not seen until now, so this would be a bit different, but I'm explaining to you how basically we see how the concept comes. Like this is an inner class, so basically it would be called using an object, since this is not static, and since this is an inner class, So first we would need to create an object of the outer class, and then we would need to create an object of this inner class. This is some kind of like chaining of objects, like outer class object, then dot inner class object. And this is like providing a reference. This is providing like reference. So this is your reference variable. So what you can basically do, inner object dot print. So let's first try to run the first thing. See, welcome to Java training. Now let's comment this out. Let's try to run this. Welcome to Java training. So you can choose to call this uh, inner class methods this way as well. Hope this is clear, right?
Return from the first example.
First example, right? The previous one you want
Yeah.
me to see?
Yeah.
Okay.
So from this we have two methods. Yeah, two such methods. From outer method and the second one
Yes.
for yeah with print. So this one when we use outer dot, so outer I think it indicates access to the uh, class or the method,
See,
but
yeah.
this outer is as a variable or what indicates?
Sorry, can you repeat your question?
Yeah, for this is outer this indicates it is for as a variable.
No, this outer is basically your class name. This outer is basically your class name, right? So this outer is your class name. This inner is basically your inner class name. This is class name. So the syntax is outer class name dot inner class name, then dot inner class static method. So this is basically the syntax. So this is your outer class name. When you write your outer class name dot, right, so it gives access to all the static methods or any static class. So these are now accessible. Now you want to access this particular method, right? So to access this particular method, this is again in another static class. So basically you want to do again inner and then dot print. So this is for how you can basically access the static method of a static inner class. Is it clear now, Gaso? Hello?
Yeah, we'll see for the next example.
No,
And
let me know if there is anything in this static inner class that you did not understand. See, let's forget this part now. Let's forget this part that I don't have this part at all. So rest of the things you had already seen, right? Creating a class and then creating a static method or creating a non-static method. And in that main method, we can like already always call this, right? So these things we had already seen. What I introduced new in this class was a static inner class, which basically contains a static inner method. And how you can basically access this is using the outer class name, which basically gives you access to this method as well. It gives you access to this method as well. Sorry, this static class as well. And how you can now access this one is using the class name of this inner class. Why? Because this static method is related to this class, this inner class. See, for example, if I just remove the outer class and I have only this inner class and print method. So how basically I can access this? Inner dot print, right? I can use inner dot print. Now I have an outer class as well, and this main method is in the outer class. So what basically I can use outer dot inner dot print. So this is the thing. And in this example, in the nested inner class, what was the difference? The difference was very plain. Like instead of using this static, this is a non-static class. So we did not have the keyword static over here, and there's a method which is like non-static method. So we do not have any static here, anything a static. And so anything which is like non-static has to be called using a object creation. I will repeat this again, and I have repeated this several times. Any non-static methods or non-static inner classes will be called using object creation. Got it, guys? So see, this is a class, this is our inner class. So how,
Yes, Prita.
yeah, how this will be accessible? For this to be accessible, first we create the object of the outer class, and then we need to access this print method as well, right? So what we'll basically do, we'll create the object of this inner class as well, dot new inner. So see, this is a non-static method, right? You see this. So that is why we need an object to call this. And what is this part? This part is basically a reference. This is your inner object is basically your reference. So outer dot inner, because this inner class is within the outer class. So we'll have outer dot inner and then the reference, and using the reference you can basically call your print method. So this is it. So once you run this, you can get your output. Welcome to Java training. So this is the reference that you are using to call this inner method of the inner class. Hope this is clear now.
Yes, sir.
Yeah, okay. So we have seen this example, like this was another example, means using that static nested classes only, and we had seen this inner class as well. Let's see some theory as well. We had seen the example of inner classes as well, demonstration. But see, the non-static nested class is called inner class. So this is what I was explaining, right? The non-static nested class is called inner class. It forms non-static member of outer class. So anything that does not have the static keyword is non-static, and this is a member of the outer class. So you should nest a class within another class when the nested class makes sense only in the context of its enclosing class, or when it relies on the enclosing class for its function. So when the inner class basically makes some sense or context that you need to enclose it and have some methods, then you can go for this inner class. So being a class member for nested class, you can specify its access modifier like any other members we have taken the, okay, this is like they have created some other example in displaying this. So they might have created some linked list class. So once I show you the collections demo, right, when we go for collections, Java collections, then I will show you more examples on this inner class as well. So we can basically use in those applications, this is like used. So but for now I have already shown you this demo. Will as we progress further using this Java collection framework, then I'll show you how basically we can use that as well. See, the other language allows you to create deeply nested classes. It is generally not recommended to do so. Nesting of classes beyond one level becomes difficult to read and understand. So you don't want to always use these nested classes, but sometimes if the practicality of your inner class is such that you do not often use it anywhere else, you want to use it only in the class that you have created it. So in that case, you can go ahead for the nesting of classes. So this was like some example of the inner nested class. We had seen some different. So these basically here they are using a linked list. I'll show you. Linked list is basically these things are of Java collection framework. So that's why I've not taken this example. We'll we can take this example once we start reading Java collection framework. But I'd shown you the demonstration of inner classes. Okay. Solomon, did you not understand this one? Okay. Okay, we'll go ahead with other topic. That is like anonymous inner class. So this is like another class type of class that is like anonymous inner class. And anonymous inner class is basically like it's an inner class, but it is declared without any name at all. So we do not have any name while we create this anonymous class. So there are two additional types of inner classes. You can declare an inner class within the body of a method. Such a class is called local inner class. You can also declare an inner class within the body of a method without naming it. These classes are known as anonymous inner class. So see what happens in a class we have a method. Suppose we have a class and in that class we have a method, and within that method we created some class. So that is called local inner class. That is called local inner class. This local inner class is not very widely used, means this is like very rarely used. So I'll not take this example. I'll show you how basically we create anonymous inner classes. So anonymous inner classes are used sometimes, but these classes do not have a name. That is why this is called anonymous inner class. That is, your inner class does not have a name. So these classes can be termed as anonymous inner class. So a situation where you would need to create a child class that extends a parent class and override one or parent class methods and needs creating single object of child class. Writing a separate class and increasing count of classes in application is not a good option, but it's the right place for using an anonymous class. So see, what this basically does, you have a parent class and then you have you want to create some child class where you want to like override that method in that parent class, and you want to use this only for this particular class. So what you will basically do, you can go ahead and try to create an anonymous inner class. So when you create that anonymous inner class, you can basically override the method in your outer class. So let me try to demonstrate this one. Let me try to create another package within this inner class that is like anonymous, and then I'll create a class, and let's say this class is some utility class, and this has got some method. Let's say it has got some display method. So let's say we want to print out something. So let's say display method of parent class, or let's say super class. Now let's say I have some other class. Let's say I have some test class over here. And what I basically do now, what I'll try to do is I will try to create an object of this utility class. Utility utility is equal to new utility. So when I do something like this, okay, once again. I'll print out some statements here. And then outside of this, what I basically do, I create a main method, and what I'm trying to do is I'm trying to call it using a utility.display. So see what we are basically doing. Let me try to first run this. See, display method of super class called, and then this in utility class display. So let me try to explain this. So what we basically did here, we created, this is also a class, but this is an anonymous class. We created an anonymous class. So this part is basically an anonymous class. So we are creating an anonymous with utility as our base class or parent class or super class, you can say. So what we are basically doing, we are creating, see, forget the static as of now, forget this static as of now. So what we did, utility is equal to new utility. So this is like creating an object, right? This is how we used to create an object. But once you provide a parenthesis here, once you provide a parenthesis and this closing parenthesis close, just remove this as of now. Let's say we have removed this as of now. So, and let's say we have removed this as well. So we have utility is equal to new utility, and then you have one opening and closing braces. So this is the structure of your anonymous inner class. Now what you will basically do here is, in this inner class, basically you provide a definition of, suppose, void display. So in your utility class as well, you had this display, right? This display method. So in this test class, what you will basically want to do, you will create your display method, and you have some use case where you want to call this method as well. You want to call this method as well. So remember, in a parent child class relationship using inheritance, we had seen that methods can be called using super.display as well. So here this utility class is basically acting as a parent class for this, but we do not need to like extend, use the keyword extends. This is like a special case of anonymous class. So basically we are calling, we are creating an anonymous class which basically is extending this utility class but in a different syntax. So this is the syntax of anonymous inner class, and we had overridden that method void display. Let's say I don't want to call this, so which method will be called? Only this print will be called. Since we are not using super.display, so this display method will not be called. This we had already seen, right? How basically we call a parent class method using a super dot method name. So let's go ahead and run this one. So we just see that this gets printed in utility class display. So now that I want to call the parent class method, I can go ahead and try to use this super.display method. So whatever was there in the parent class method gets printed now. So, and what I'll do to access this anonymous class, since I'm calling this from a static main method, so I would need a static, I would need to introduce this static variable such that static members can be called in a static method. You remember, right? And non-static members cannot be called in a static context. So if I remove this, I'll start getting error. I'll start getting error that non-static field utility cannot be referenced from a static context. So that is why we basically need to make this keyword as make this anonymous classes static. So once we make this a static, we can basically call this utility dot display in this manner. So this was an example of anonymous inner class. So we'll keep the class to this concept only today, and if you have any questions from these topics you can ask, or we'll conclude the call for today. I'll share these contents by today and the lecture will also be uploaded. So if anyone has any questions about this inner class, static inner class or anonymous class, you can feel free to ask now, or else we'll meet tomorrow. Okay, let me stop the recording.
Recording stopped.